In this video, we're going to be talking about graphing straight lines, and that's going to be using a table of values. In our first example, we're going to plot a graph from a rule. Now, what a rule means is that we're given an input, so in this case, 2x minus 1. The input is whatever we replace x with, and then we're going to get an output, which will be y. So that's the rule. And you'll be able to see once we put in table values how that rule works. Okay, so we're going to plot the graph of y equals 2x minus 1 by first completing the table of values. So here we've got a table of values given to us. It's x and y, and we've been given 3 x values that we can substitute in. Okay, now when you're substituting in values in a table like this, I want you to imagine that the x, of course, we draw it like this. Okay, we always draw it like that, but you'll notice that on a calculator there's no real x that we can use. There is an x here. If you press alpha and then this bracket, we get an x, but it doesn't do anything. In this case, it says 0. No matter what we do with this x, it's always going to result in some useless response. Okay, so aside from that x on there's nothing that can really use for this x. So what I'd like you to think of, instead of an x, whenever you're using x in a calculator, I want you to think of two sets of, like a set of brackets. So 2 brackets, just like these ones here. Okay, and it's easy to remember because there's an x there, of course, the one we were just talking about. So you can use these 2 brackets. When you use those, the calculator's smart enough to know exactly what you want to do with that x value. In this case, it'll be a bracket value. Okay, I just want you to get your head wrapped around that first. To give you an idea, we're going to start off with just substituting in these values, and -1 is a bit weird, so we're going to start off with 1 and work backwards. Okay, so the first case I'm going to show you, we're going to do y equals 2, and then instead of x, we're going to do brackets minus 1. Okay, and I'm going to type that straight into my calculator as well. Okay, we have 2. Obviously, we're not going to type in y equals because that's our output. So we want 2 with the brackets minus 1. Now in those brackets, you can use the replay buttons to find that space. I'm going to replace that empty space with one of these numbers. So we're going to start off with 1. So when we make it a 1, we'll be given a value. In this case, it's going to be 1. So I'm going to put that answer right there in the table of values. It's the whole purpose of us doing this, okay? So we've got our 1 value. I'm going to go back in, change it to a 0, and now we get -1, okay? And we'll go back in and we'll change it to -1 this time. We get -3, okay? Now we do this so we don't have to just type it in every single time, and we don't have to think about it at all. The x is there, we pop it in brackets, and then we get our answers. Okay, now we have this, we can see why this is called a rule. Okay, if we start at -3, to go from -3 to -1, we've gone up by 2, and to go from -1 to 1, we go up by 2 again. So in this case, the rule is that we're going up by 2's. But as we've got here, 2x, that means the 2 in front of the x means we're going up by 2's, and there's a -1, and that means at 0, we're starting at -1. That's what the rule is. Starting at -1, we go up by 2's, so negative or down by 2's in this situation. Okay. Once we have that, we can plot these points. So what we've got here, we've got the x values and the y values. So for the x value of -1, so here we've got -1, we go down to -3, and we put a little dot. That's to represent that point. Okay, we'll do it again for 0. So when x is 0, this is the x-axis, x is 0, we go to -1. And then when x is 1, y is 1. Okay, so we go up 1. Once we plot these, we can actually graph it by just connecting the dots. So once we do this, we'll have the graph of the rule that we're just discussing. I pop arrows on the ends to say that it keeps on going, because just because I've graphed it to these numbers doesn't mean it won't go on forever, because in this case it does. And just for good measure, I like to label these, just in case you want to write 2 on there, okay? So this line is y equals 2x minus 1. Okay, now we've got that basic idea of how this works, we're going to do another example. In this case, it's interpreting a graph when given a table of values. The question asks, Jasmine is organising a school dance, the venue is chosen and the costs are shown. Okay, so for the number of students, and they vary, we have a cost. So when there's 0 students, the total cost is 500. When there's 100 students, the total cost is 1,000, and so on. Okay, so the first part says to plot a graph of the total cost against the number of students. Okay, and then there's part B. We'll look at that in a moment. So let's first start off with A. Here we've got our graph. Now all I've done is just done the axes, just because I did a bit ahead of time just to make sure it was all nice and neat. Now our S is here, so that's the number of students, and we've got our C here, which is the cost. So I'm going to plot on these dots, I'm going to put numbers going up at the same rate. Okay, so for the number of students, we start off at 0, of course, and I'm going to go up by 50s. I'm only going to write every 100. Okay, that's just to make it a bit neater. We understand that that's 50, that's 100, that's 150, that's 200, and so on, but we just want to give you an idea of how it goes. Now on this side, I'm going to do the same thing. I'm going to put down $500 here, skip one, $1,000, skip one, 1,500, and then 2,000. It's a good idea to do this in pencil, just in case you make a mistake. I did it in pen just so it's easy to see. Okay, but try and use pencil if you can. Now that we've done this, we're going to plot these points. Okay, so when S is 0, C is 500. Okay, so I'm going to do a dot there. When S is 100, C is 1,000. So we're going to have a dot there. 200 and 1,500. And 300, 2,000. Now if you have grid paper, this is a lot easier, but if you don't, just give it your best shot. You can rule lines, whatever you need to, just to get an idea of how that will work. Now I've done that, I'm going to connect all the dots, and that will keep on going up that way. Okay, we don't know if it continues this way because, of course, we start off with 0 students. You can't have a negative amount of students, so it starts here and just continues upwards on that trend. That's why I've only done one set of arrows. So that's our graph showing this table. Now that we've got that, we can use the graph to determine, so this is part B, we're going to determine the total cost for 150 students. So we need the graph in order to determine 150 students because we don't know what 150 students will cost. So we know that this here, that's going to be 150. That's 150 there. I'm just going to do a dotted line up to the line. And I'm going to use that point here. So this is our I point, the total cost for 150 students. And we can see that will be the number in between 1,000 and 1,500. So you can find the average of those two points, or just find in between. We know that for I, it's going to be $1,250. Okay, based on this. So we start here and we go up and then across, and then we get this point here, which is the number in between $1,500 and $1,000, which gives us $1,250. If you want to see a way of doing this, you could add them together. So 1,500 plus 1,000, and then if we divide it by 2, we get our $1,250. That's just one way of doing it. You can also interpret it however you would like. As long as you get to this value, you've done it correctly. Next, we've got part 2. How many students could attend with a budget of $1,750? This is the opposite of what we did. So we started with the number of students, went up and across. We're going to start with the cost and go across and down. As we know, this is $1,250, this point. We're going to start here, which is the $1,750 point. Okay, so we're going to go across till we hit our line, and I'm going to go down, and we can see that it will end up at this point, which is 250. So for part I, 250 students can attend. Okay, and that's how we answer that example. Last, we have constructing a table and graph from interpretation. So what this means is we're going to take the question, identify the rule, and then put it onto a graph. Okay, so first of all, here it says an electrician charges $50 for a service call and $60 an hour for labor. Now this is like quite a real life application of this idea, because of course you'll pay in the future, you'll pay for people to do things for you, and this can help you get an idea. You may be this electrician and you might need to understand how you'll be getting paid and determine how much you'll earn in a day. So first of all, let's say you don't work any hours. You still charge $50 for the call, for actually going there. So we're starting at $50. And then every hour after that, you get $60. So $50 plus 60 for 1 hour. We get $110. So that's our value for that. And then we'll take that 110, add 60 again. We get 170. We'll just keep going, adding 60, adding 60, and then again. Now you'll notice I used a calculator for this. As long as you have access to a calculator, there's no reason why you wouldn't use a calculator for an application like this. Now that we've completed that, part B asks us to plot a graph of cost against number of hours. So here we've got, I've already done the axes, we've got number of hours and this is the cost. So first we need to label the axes. So the number of hours, we have to start with 0. That's 1, 2, 3, 4, 5. Could possibly go further. And for how much the cost will be, we can see it starts off at 50, goes to 350. Our graph needs to start at 0 here. So as we go up, let's make it going up by hundreds. 100, 200, 300, 400. Okay, so we'll stick with that for the moment. And now when we plot this, we're going to have, initially at 0, we'll have 50. And then at 1 hour we have 110, so that's just a bit over 100. And then 2 hours we have 170, so that's going to be just below 200. We'll just keep going. Now the key to graphing these things is, yes, we've got 6 points here that we could use. However, once you've got 2, preferably 3, when you're just plotting points, you can connect them and it will project up until where you'd probably stop, possibly further. Okay, and let's just quickly check that. So at 5 hours we should have 350. So if we look up here, we'll do just a small dot so we can see. You can see that's about halfway between 300 and 400. So this is a pretty accurate line to help us answer this question. So you don't need to use all those points in order to actually graph this. Next, we're going to use the graph to determine 2 things. We're going to determine the cost for 4.5 hours of work. So we know that the 4.5 hours is between 4 and 5. So I'm going to do a dotted line up from 4.5. So there, that's 4.5. And we're going to go across. Okay. So for 4.5 hours of work, that looks roughly to me, well, it's going to be less than 350. That looks to me about possibly 320. Now, the more accurate this graph is, the easier this question would be. So 320 was my answer for part I, and for part II, how long the electrician will work for $260. we'll find 260. It's going to be just above, we're halfway between 200 and 300. Go to the red line and we'll go down. So looks to me about 3.5 hours. Okay, so 3.5 hours of work. So hopefully that gives you a good idea of how you can answer different types of questions about graphing straight lines and interpreting tables of values and things like that.